All right, just so everybody knows, I'm recording my screen share and the audio that comes in. Um, so I don't know, do what you want with that information. Um, Loki, I went through the start of this a while ago, and then I just finished it, so uh, might have to relearn these first few problems, but we'll get through it. It's fine. Okay, so this first one is marginal rate of substitution. It's a pretty common formula. It came up a couple of times, so it's definitely one that would be helpful having on your uh, note card thing. So you're supposed to know this formula right here, and it gives you mg, mug, and it gives you mum. So all you have to do is plug those in. So you plug in the 1 over g and the 1 over m into this formula right here. And then you're asked if m is at 10 and g is at 4. You also plug those into the m that's right here and the g that's right here, and you get 1 over 4 over 1 over 10. And then 1 over 4 divided by 1 over 10 is the same as 1 over 4 times 10. Either way, that's 2.5. So that's our answer for that one. I'm just going to ask for question. If you guys have any questions for the problem I'm on, feel free to interrupt. But other than that, I think the meeting is only like an hour, so I kind of just want to get through this. Um, all right. Same thing, marginal rate of substitution. This one is tricky because people get tripped up on this answer. Um, it's it I I can't really say why. Like I don't know exactly why, but I just know that you can't change the M and the R. So if you're given R and M, you can't change that into M and R. Um, and I don't know why that is. I just know that that's what it is. So if you plug in like MRS, MRS for M and R, you're gonna get like 4 over 2, which simplifies into 2, and you would think that this is right. Um, but it's not because this right here, it's this part right here. So M over R, that would mean that the MRS, the marginal rate of substitution, would be dependent on how much of each they bought, right? So marginal rate of substitution doesn't change. It's a rate. It's not dependent on how much they bought. It like shows how much they bought. So marginal rate of substitution is always going to be just one number. So it's never going to have this m over r. It's always just going to be 2. So that's why this first one is wrong. We know that these next two are wrong because they're in difference curves or vertical or horizontal. We know that's not true because she has a marginal rate of substitution. So if the curve was vertical, then there's no substitution. As income rises, like as this budget curve rises, then she's just going to buy more of X or Y. She's just going to buy more of X. Y, she's always just going to buy a standard amount of, right? Because this never changes. This is always the same. This is the only one that changes. So there's no substitution. And it's the same thing. And if it was horizontal, it would go for X instead of, or it would go for Y instead of X. So if this curve is right there, then, oops, the X would stay the same and the Y wouldn't change, or the Y would change. So as income increases, so if we have a second budget curve, then y moves from here to here, and x doesn't change. So there's no substitution. So we know that the curve is not horizontal or vertical, which takes out those two answers. So not that, not that, not that. And that only leaves one, but I'll still explain this one. She's willing to give up 2 tubes of regular flavored toothpaste for 1 tube of mint flavored toothpaste. So utility is given by 2R plus 4M, right? So this is the amount, this is like how valuable each one of these things are. So she's willing to give up 2 tubes of regular for 1 tube of mint flavored toothpaste. So she's saying that mint flavor is 2 times more valuable than regular flavor, right? Because she would give up 2 of the regular ones just for 1 of those. So mint is way better. And we can see this in the utility function because a much greater value is put on the mint flavored toothpaste than the regular flavored toothpaste. Like she gets more utility out of it, right? So both of these are, if she has 1 regular and 1 mint, then she's getting 2 utility from regular and she's getting 4 utility from mint. So mint is worth more, it gives her more utility. So she'd be willing to give up 2 of those regular flavored ones for 1 mint flavor. Hopefully that made sense. There's not really any formulas you need for that other than just knowing how this formula works, and that you could get from this problem before. So like when we calculated the MRS, so what is MRS? It doesn't say MRS like R divided by M, it's just a number, right? So it's the same thing here. When there's that part after it, it doesn't make sense because it's not a rate anymore. It would mean that it changes based on how much of stuff they buy. So just know how this formula works. Make sure there's nothing after the rate, and you should be good. All right. So this one, Randy likes baseball more than football, football more than basketball, and basketball more than baseball. So I don't really feel like drawing those, but it's in the chapter 4 notes. Kind of one of the first things we learned were these 4 rules, and these will come up a couple of times. I know completeness and rankability comes up. This one is going to be transitivity. So if A is greater than B and B is greater than C, then A is greater than C. And since he says he likes baseball more than football, so baseball more than football. And he likes football more than basketball. He can't like basketball more than baseball because if we were doing like a ranking system, then baseball would be at the top, and football, and then basketball. 1, 2, 3. It's impossible for 3 to be better than 1 because it's 3rd place. This one, it's pretty simple. You just have to know what kind of rule that violates, what it's called, and it's transitivity right here. I don't think you can put that on your note card because he said no definitions, but just kind of look over these, make sure you know. The only 2 that are like kind of definition and aren't self-explanatory is transitivity and completeness and rankability. For the other ones, those are just kind of given. It's not really definition, it's just kind of like a rule. So if I had to look at 2, I would look at transitivity and completeness and rankability. All right. Suppose that utility equals utility for PM, peanuts and marshmallows. The marginal utility of marshmallows, MUM, is given by what? Okay, so marginal utility is going to be marginal and delta all often go hand in hand. Um, so marginal is like how much you get from like doing one more, and delta is the same as saying change in. So like if I went from 8 to, oop, come on, 8 to 10, then the delta would be 2. Okay. And marginal is just how much you get from doing one more. So a lot of times you'll see those together. So it's a good hint when you're looking for marginal utility, which is what this M is. Come on, M. Then it's a good idea to look for these delta symbols. So that's kind of a good trick to help narrow stuff down. And then just kind of look at what these other two are saying, right? So the utility divided by the change in marshmallows. So we're like the question said, we're looking at the marginal utility of marshmallows, right? So this M right here isn't talking about marginal like the M here is. It's talking about marshmallows. So this would be saying the change in utility over the change in marshmallows, which kind of sounds like the marginal utility, right? How much do I get from getting one more? So plus one over here, how much would this be, right? Um, I know I'm not really the best at explaining this or putting this stuff into words. It's just kind of how I think about it. Um, you see multiplying here, that doesn't really make any sense because why would you, like, um, if I changed from 8 goods to 10 goods, um, and that, brought me, say, 24 utility, then the marginal utility would be how much I got from each one of those goods. So I would take 24 and divide that by the change right here. So that would be delta, and that would equal 2. So I would be dividing by 2. It wouldn't make sense to multiply this by 2. Um, I don't even know what that would mean. I just know it makes way more sense to divide by 2, because like I said, the change in here is 2, so divide that in half to see what each of them, the marginal utility, is for each of those. Like I said, I know I'm yapping, kind of explaining myself in circles here, so if you guys have any questions or you need me to explain it in a different way, just let me know. You could memorize this formula. It wouldn't be a bad idea to have it on um, your formula sheet. Just know that this M isn't, like, it can change. So we're talking about marshmallows here, and this P could also change. So these are variables. You could be talking about like nuts and chips. So it would be an N and a C. So just know that these change based on what you're talking about. This M is talking about marginal. This U is talking about utility. These will not change from formula to formula. So I'd recommend doing like MUX equals delta U for X, Y over delta X. That would be what I would put on my formula sheet, just so it's more obvious that these are variables and not, they don't, like, this M doesn't have anything to do with this M, if that makes sense. All right. This one, good X and good Y, which of these changes would have rotated the budget constraint in the direction indicated by the arrow in the graph? Okay. So remember, whenever we increase the price of one of the goods, we're rotating it. Okay. So, and whenever we have a change in income, we're changing the entire line. So when it's saying rotating, we can see that the quantity of good X doesn't change. Like both of these lines stop at 8 right here. But the quantity bought of good Y does change, okay? It changes from 9 and it goes down to 6, okay? So we're trying to think what would cause that? What would cause me to still be able to buy the same number of good X? So I could still buy 8 of good X, but now instead of 9 of Y, I could only buy 6. Okay. So our budget didn't change. We know that because the graph rotated. Um, like this didn't change. So if my budget was lower, like if my budget was in half or something, then both of these would change, right? So this 9 would go to like a 4.5, and X, this 8 would go to like a 4. So that would be like a budget change, right? The slope of these two lines is the exact same. So we move the entire line. That's what a budget change looks like. And it can go either way. So it could go like out here. As long as these slopes are the same, that's going to show budget, or income or budget, whatever you want to talk about. Same thing in this scenario. But we know that the price of one of the goods changed. So since we can buy the same amount either way for X, we know that X didn't change. We know that Y changed. So we know that's wrong. We know it's not income, so it's down to these two. Um, if the price of good Y decreases, that means I'm going to be able to buy more of it, but that's not the case here. I'm actually going to be able to buy less of it. So we know that this is an increase in the price of good Y because I'm not able to buy as much as I would at the start. So that's that one. No real formulas here, just a kind of concept question as far as like, being able to read one of these graphs. All right. Spends all his money on movie tickets and groceries. Suppose Ahmed is choosing between two options, A and B. Option A gives him a voucher of a certain amount of money that he can spend on groceries. I'm going to say that that's 10 just because it's easier to talk about that way. Option B gives him X dollars that he can spend on either or both of the goods, which is correct in assuming Ahmed is indifferent between the two options. Okay. So we're looking for basically what makes sense, right? So I'm going to start from the bottom up. This one's more of a process of elimination one, but since the correct answer is at the top, I'm going to eliminate the other ones first. So Ahmed spends his entire income on movie tickets. So he's got a voucher. In scenario A, he's got a voucher for $10 for groceries. So if he spends all his money on movie tickets and he doesn't buy any groceries, then that's $10 wasted, right? So that doesn't make sense. You don't want to waste money. So next one, Ahmed must be indifferent between movie tickets and groceries. So the whole question is which is correct, assuming Ahmed is indifferent between the two options. Ahmed must be indifferent between the movie tickets and the groceries. If he was indifferent, then he could do this. Like he wouldn't care if he wasted the $10. He could spend groceries, movie tickets, if he did like that. If he was indifferent, then anywhere along this curve would be his maximizing utility. Like utility curves are all over this thing. But we know that he's not indifferent because he has this $10 grocery voucher. So this one does not make sense. Ahmed spends less than $10 on groceries. We know that's also not true because if you spend, say, $6 or $8, then he has, was that 4 or 6? No, $2 or $4 left over. And again, that's basically money wasted. So we want Ahmed to spend at least X amount on groceries. So at least $10 on groceries. That's the only one that really makes sense. So that's the answer that I chose. Holy cow, 18 people. That's pretty cool. All right, for newcomers, I I'm not really experienced in teaching, so if I need to explain something in a different way or slow down or anything, feel free to interject or send something in the chat or whatever. I'll ask for questions at the end too if you want to wait until then. But yeah. All right. Sophia spends all of her income on pizza and gasoline. Suppose Sophia is considering two options, A and B. Option A will subsidize gasoline by decreasing its price by 50%. So we're decreasing the price of one good, which is gasoline. So gasoline goes down. This is A. Option B will increase Sophia's income. So income or purchasing power goes up. So that's going to shift the entire line. And then assuming Sophia, oh wait, option B. Oh, so it will increase Sophia's income by the cost of the subsidy in option A. Okay. Assuming Sophia strictly prefers option B to option A, which one must be true? Okay. So if we're given that she prefers option B. So we're asked, why does she prefer option B? Okay, so if option A happens, then the price of pizza stays the same and the price of gasoline goes down a little bit. Okay, and this would be good if she was only buying gasoline, right? If she actually, this graph would go the other way because her quantity bought would be higher, like that. So this is quantity of gasoline. So since the price of gasoline goes down, then the quantity demanded will go up. But anyways, if she's only buying gasoline, this helps her a lot, right? But if she's buying anywhere else, it only helps her a little. And if she's only buying pizza, it doesn't help her at all. Okay. So the next one is, so that's if she only consumes gasoline, then she would be preferring option A. We want to know why she prefers option B. So this one's wrong. Sophia gains more utility from gasoline than pizza. This one we don't know. We don't know how much utility she gains from either of them. We just know what kind of like what her demand will be at each of the price points. So we don't know how much utility she gets out of producing either of them. So we can't talk about it at all. Sophia gains more utility from pizza than from gasoline. Again, we can't really talk about utility because we have quantity demanded and we don't have anything else. So utility, it's we can't just like we'd have to make up a whole new graph for it. So the only way that she prefers option B with the income. Let me see if I can clean this thing up a little bit. So P, G, so her income increases. That would help her out on both of these goods, right? She can buy more of both of these goods. And the only way that she strictly prefers A and doesn't prefer, or strictly prefers B and doesn't prefer A at all, is if she's consuming at least a little bit of some of each of the goods. So that's why the answer is A. If she was producing, or if she was consuming only one of, or if she was, yeah, if she was consuming only gasoline, then she would prefer option A. And if she was only consuming pizza, then she would be completely indifferent. She wouldn't care if it was A or B. And the only way for her to prefer B over A instead of being completely indifferent is her consuming at least one of each good. All right. So suppose a consumer spends all income on goods X and Y. Suppose that the price of good Y increases and the consumer's income decreases, which must be true. Okay. So this is our original one. This one is OG. And then we're going to do shift 1 happens when the price of good Y increases, so they can buy less, right? So we're going to shift this, we're going to rotate this. That's why this stays the same. This quantity demanded of X stays the same, but Y changes. And then the second thing that happens is the consumer's income decreases. So that's number 2. We're going to take the slope of this line right here, and we're going to duplicate it. We're just going to move this entire line down. So this is after kind of modifier 2. So which must be true? The amount of good Y that the consumer can purchase increases. So the price of Y increased, so the quantity demanded will decrease. They can't buy as much because it's more expensive. So this is wrong. We can see that the quantity they can buy is down for Y, and it's also down for X, right? At any point along this, it's lower than it originally was. So the amount of good X, the amount of good X that the consumer can purchase increases. We can see that that's wrong. Sorry, my nose is really itchy. We can see that that's wrong at every point along the line. They decrease for both of them, so that's wrong. The amount of good X that the consumer can purchase decreases, and the amount of good Y that the consumer purchase increases. Nope, they both decrease. The amount of X, so this is wrong. The amount of X and Y that the consumer can purchase decrease. Yep, both of them decrease. That's our right answer. So it's D. All right. Again, no formula for that. Just kind of be able to make a graph out of a question, I guess. This one, it's easier to, at least for me, to just draw it out. I can kind of visualize it better. I'd recommend doing that. So which is not a result of completeness and rankability? So again, back over here to our kind of rules of consumer preference. So customers are able to choose what they like best, right? So a person prefers one consumption bundle to another. Yep, they can choose what they like best. That's good. A person is indifferent between the two consumption choices. That's fine. They can be indifferent. A person likes jelly bean more than hamburgers. So this, it's not, it's too specific. Like you can't, like this isn't a rule for everybody. Um, these rules are for everybody, right? We're just saying that they can like one or the other, or they can be indifferent, but we're not saying that it's not a rule for specific people, if that makes sense. So being specific like this, it's not a rule. So that's why that answer is correct. And since that one's incorrect, then they can't all be right. So answer C. All right. Which of these statements is true? So we have a utility curve of U2 and U1. Utility at U2 is 120. Utility at U1 is 100. Consumers not willing to give up units of good X for more units of good Y. That's not true. If that were true, then it would look like, what would it look like? That, I think. Yeah, it would look horizontal. So we can see that these are curved lines. Anything with a slope, they're going to be willing to kind of make a trade-off there, as long as they're not completely vertical or horizontal. We're going to skip the other ones just so it's process of elimination. We're going to skip the right answer. The customer receives 20% more satisfaction from consuming along the indifference curve 2 or U2 than along indifference curve 1. So we see that there is a plus 20 here. And, some people might, jump to conclusions there, say, oh, that's 20%. But that's not true because of this rule right here. So consumer preferences are ordinal, which means we can rank them, but we can't say that they like something 20% more. We can just say that they like it more, okay? So we can say that we can say that they're going to be happier at U2 than U1. So we can say that this is greater than this, but we can't say that this is greater by 20% or some like specific number. We can just say that this is better than this, which brings us back to answer choice 2. The consumer prefers any point on a difference curve U2 to any point on a difference curve U1. That will always be true. All right. Again, no formula there. So just kind of know how utility works and make sure you don't get tripped up on the 20% thing. All right. This one's a little wacky. I'm low-key still having trouble understanding exactly how this works. But I'll kind of explain my thought process. Anyways, Yana's ratio of marginal utility for coffee and soda is 3 to 1, whereas the price ratio of coffee is 1 to 5 to 1. Which of these statements is true? So this goes all the way back to it goes back to that first formula where it's looking for a marginal rate of substitution for xy equals MUX over M. Oh wait, no, that's the wrong formula. My bad. We're using this formula. So MUC over PC equals the what am I looking at? Coffee provides. Sorry, I need to reteach myself how I did this. Oh, okay. Yeah, so we're given marginal utility for each of them in this ratio right here. So marginal utility for coffee to marginal utility for soda is the same as this, so 3 to 1. And the same as price. So we have 1.5 to 1. So for coffee it's 1.5, for soda it's 1. We plug it into this formula to get the marginal utility per dollar, the change in utility per dollar, so the marginal utility. So the marginal utility of the coffee is the marginal utility divided by the price, which would be 2, and the marginal utility divided by the price of the soda would be 1. This is where I got tripped up because you can see that she gets more utility per dollar for coffee than she does for soda. So we're looking to increase the price or increase the amount of coffee she drinks, decrease the amount of coffee or decrease the amount of soda she drinks because she just gets more value from the coffee. So we don't want to decrease the coffee by 1 because coffee is worth more, so that's wrong. And again, we don't want to decrease the coffee. So I know that these two are wrong. This is where I kind of got tripped up and lost. I couldn't decide between these other two answers because I didn't know like how much she should be decreasing by. I'm gonna be honest, I don't know how to decide between these two questions. This question is kind of a toss in the air for me. I plugged it into ChatGPT. Let's see what it's set for 11. The consumer can improve shifting by spending. Yeah, I still can't I still can't wrap my head around it. So if anyone has a better explanation of how they got to answer C on 11, I mean I checked it with the key he sent out and C is right. I just can't explain why it's C and not D. Like I assume it's got something to do with how much she can purchase. Like her marginal utility. I think it has something to do with like her marginal utility for both of them should be the same. So the amount of utility she gets from each of them should be equal. But like I said, I can't really help on this question because I couldn't figure it out. So I can knock out A and B. Those are pretty easy, but between C and D, I can't really tell you why C is correct. So I guess sorry for that one, but um, oh well. If there was like a question that I would put more effort into learning about, this is going to be the question. So after this, I'm probably going to take a look back at it and see if I can figure it out. But that's where I'm at right now. So sorry about that one. Moving on. Okay, Sophia's utility is a function of golf and music lessons, where the marginal utility for golf is 1 over g, and marginal utility for m is 1 over m. What's the equation for the marginal rate of substitution for music lessons for golf, MRS GM? Okay, so this is the same formula from that first question a while ago. The MRS of GM is equal to the marginal utility of G over the marginal utility of M. So if we just plug that in, we get 1 over g over 1 over m. And when you're dividing by a fraction, it's the same thing as multiplying by the reciprocal. So 1 over g times m over 1, you're going to get m over g, and we have m over g right here. So like I said, this formula is going to come up a lot. So make sure you have that either memorized or on your index card. Yeah. All right, this one, he enjoys eating sandwiches with 1 slice of meat and 2 slices of cheese, which market bundles provide Nikolai with the highest level of utility. Okay, I like to look at this in the amount of complete sandwiches he can make. So if he wants 1 slice of meat and 2 slices of cheese, if you have 4 of each, you can only make 2 complete sandwiches, because the cheese is your like limiting factor on that. If you have 3 slices of meat, 6 slices of cheese, you can make 3 complete sandwiches. If you have 2 slices of meat, 2 slices of cheese, you can make 1 complete sandwich. And if you have 1 slice of meat, 2 slices of cheese, you can make 1 sandwich, right? So which one of these can you make the most sandwiches with? Which one is going to be more happy with? It's B. All right. Assume that the price of good X is $100 per unit and the price of good Y is $100 per unit. When income increases from 1200 to 1600, good X is a blank good. Okay. So price of X is $100 per unit. $100 per unit. And we're looking at the increase from 1200 to 1600. So which one of these budget curves are we looking at? We want to start when he has $1,200, so he can buy 12 things of good X because they're $100 each. So we know that this is the $1,200 mark to $1,600 mark. Same thing there. So it's that move right there, which is between these two things right here. Okay. We can see that that curve is very steep. And if we look over to our notes for chapter 5, for normal goods and necessity goods, luxury goods, all that other stuff, we can see that the elasticity for good X, which is, we're only looking at good X here. Okay, so from here to here, from here to here, he is the amount it increases on X is only 1. Although he went from 1,200 to $1,600, the amount of increase that he's buying for X is just 1. Whereas for Y, it went from 5 to 8, so that would be a plus 3. So for X, Y. All right. So we can see that given this large increase, this $400 increase in the budget, the quantity consumed did not change much. Okay, so if we had like, if we took the percentage change, I don't know what that is exactly. It was 33%. Okay, so 33% change in income, what was the change from X? That would be from 7 to 8. What's 1/7 in percentage? 1 divided by 7. It's a 14% increase. So a 14% increase. Oops. So a 14% increase divided by a 33% chance, or a 33% increase in what's it called? In income. It'd be, you'd multiply by 3, so that's like 30, it'd be like 42, I think. Maybe that's right. So this would be 0.42. And we're looking at if the elasticity is between 0 and 1, which 0.42 is in between 0 and 1, they're called necessity goods, and they rise with income, but at a slower rate. So we can see that it's necessity. I would kind of go over these definitions for necessity and luxury goods and inferior goods and stuff like that. Just so you know that, like, once this number goes above, when it's bigger than 1, then it's going to be a luxury good. But as long as it's in between 0 and 1, then it's a normal good, or it's a necessity good. Both luxury and necessity are normal goods, but if it's between 0 and 1, it's necessity. All right. Okay. The substitution effect will be the largest for indifference curve blank. So we're looking at what is the least curvy curve, if that makes sense. You just need to know that the more curvy something is, so like the more it looks like, oops, like that, then the less substitution effect is going to have on it. Because this is a complementary good, substitution isn't really going to do much. But if you have a line like this, remember this is the line for perfect substitutes, so substitution effect is going to do crazy things to this graph. So the more a line looks like this one right here, the bigger the substitution effect is going to be. So this one's pretty curvy, this one's pretty curvy, this one's pretty curvy, this one's pretty flat. So U1, this one is going to be the greatest substitution effect. For this one, I would just look over, might be in 4. I would just look over this. So you want the indifference curve to be, I guess these one would work too. But you want if you want the substitution effect to be high, you want it to be more of a curve. So I don't know, just take a look at that. When the price of milk drops, the substitution effect blank the quantity of milk consumed from blank gallons. Okay, so we're looking for if it increases or decreases, and from how many. Okay, so is the substitution effect going to increase or decrease the quantity of milk? So this is, again, substitution effect is the difference from A to, sometimes it's called A1 or U1 or whatever it is. But we're looking at this difference right here. So from A to U1, it's going to increase from 2 to 4. So increase from 2 to 4. And this other one, in case it asks you a question on that, this is going to be the, what's the other one called? Substitution effect and the income effect. That's going to be the income effect. Where'd my pen go? There it is. So substitution, income, just know how to read a graph, I guess. No formulas can help you out on this one. Again, S plus I equals total. I guess you could write that, but it didn't really help you in this one. So G. All right. Okay, given the change in budget constraint shown in the figure, the demand curve for blank has shifted blank. Okay, so this concept is gonna come up a little bit. If the price of something changes, uh, it shifts along the demand curve for that. So if Y changes, if Y goes up or down, then shift on Y, or I shouldn't say shift, I should say along Y and shift X. Okay, so the demand curve is going to um, it gives a better word in the textbook, but it moves along the Y and it shifts the entire X curve. So like I said, if um, the budget constraint shown in the figure, we can see that the price of Y is changing. So if Y changes, then we're looking for a shift in X. So we know that um, we're looking for which one shifted. So we know that's not going to be Y because Y is the one that changed. And we can't be both because it can't be Y. So now we're left with if we're sure that X shifted, then did it shift inward or outward? Looks pretty outward to me. So shift outwards. All right. Which of these statements are true? Movies in a theater, movies at home could be substitute goods if the falling price of home entertainment equipment causes people to watch more movies at home and fewer in the theater. That makes sense. Movies in a theater could be um, complement goods if watching a lot of movies at home causes people to want to come and watch more movies in a theater. That makes sense to me. So they could be either or. If the cross price elasticity of demand between movies in a theater and movies at home is 0.33, then the two goods are complements. No, that would make them substitutes. So we know that it is just 1 and 2. No formula there, just, I don't know, just knowing how things work, I guess. Let's take these away. Suppose that Seth's income increases from 4 to 500 per week, so that's a 25% increase. Oops. So Seth increases his purchases of movies from 3 to 4. That's a 33% increase. The income elasticity of movies is blank. So this isn't exactly how the formula looks, but this is just kind of like the simplified version that I think about. So elasticity equals the change in quantity over the change in income. I think it gives like a capital Y as the change in income, which I don't like because it doesn't make sense to me. So I just do I because it makes more sense for income. So changing quantity. So um, changing quantities here, 3 to 4, 33%, and then change in income, 25%. Again, if you're dividing by something that's less than 1, then you're multiplying by its reciprocal, or if you just want to plug this into a calculator, you get the same thing. So 1.33. Abby's utility function is given by u equals x squared y squared. For this utility function, mu equals 2xy squared and mu for x equals 2xy squared and mu for y equals 2x squared y. If good x costs $10 and good y costs $5, then Abby will consume blank times as many units of good y as she does of good x. Okay. So we're doing this formula again, this one right here for both of them. Okay. So we're just kind of plugging things in. So mu is given right here. MUY is, MUX is given right here. MUY is given right here. Price of X is there. Price of Y is here. So just plug all that in, and then it's just algebra from there. So you see it's 10 and 5. I guess I can resolve this for you. It won't be too bad. We're gonna kind of simplify this right here. So that's going to be xy squared over 5 equals 2x squared y over 5. We can multiply both sides by 5. That should be a y. Multiply both sides by 5, so xy squared equals 2x squared y. Then we're going to divide both sides by xy. So we get y equals 2x. All right. Don't get tripped up on this and try like so we know that the ratio is not 3 or 4. A lot of people get tripped up on if it's 2 or 1.5, or sorry, 2 or a half. Remember that the y is the number of y they buy, and the x is the number of x they buy. So for these two to be equal, she would need to buy twice as many x as they do y. So or sorry, she would, for these two to be equal, she would need to buy twice as many y as she does x, because this is giving utility. So if y equals, say y equals 4, then x would have to equal 2. Okay, so y has to be 2 times greater than x. Okay, so Abby will consume 2 times as many of goods y as she does of good x. I guess I can do that. So that way we know it's 2 and not 1/2. All right, suppose the price of good y increases from 1 to 5 as shown in the diagram. Goods x and y are, what are they? Okay, so we can see that if the price of good y increases, so we can buy way less of it, then is my consumption for x going up or down? Okay, so if y was a complement to x, then you would see both of these go down. So if I could buy less y, then I'm not going to buy so many x, right? If I can only buy, like if I used to be able to buy 10 pairs of left shoes and 10 pairs of right shoes, now I can only buy or I guess I should say 10 left shoes and 10 right shoes. Now I can only buy 2 left shoes. Then it doesn't make sense to buy those 8 extra right shoes. I'm just going to want to buy 2 because that's where it would line up. So we know that they're not complements because x actually increased on this, right? So it used to be at 2 here. It increased to 5, right? So we know at some level they're substitutes. They might not be perfect substitutes because this is a decrease of like 6, and this is only an increase of 3. So they're not like the perfect one. It's not like that. It's probably closer to like that or something. But we can see they're substitutes and not complements because the quantity of good X that they're going to buy increased as Y decreased. All right. In panel A, the price of good X is $1.50 a unit, and the price of good Y is $3 a unit. In panel B, the consumer's income increased from 400 to 4,800. This is another one that didn't really make a whole lot of sense to me. I knew how to do it and but I didn't get the completely right answer when I did it. So I chose the closest answer, and that was right. And I mean, it does say approximately, but I got 20, and it was looking for 12. But it's that same income elasticity. So we have our elasticity equals the change in the quantity. So the change in the quantity demanded for, what are we looking at? For good X, it goes from 2 to 10, and it says we're only looking at panel A. So it goes from 2 to 10. That's an increase of plus 8. And from 2 to go to 8, That is a 400% increase. Ooh, somebody's calling me. Oh well. It's a 400% increase. So the delta Q is going to be 400%. Now we look at the change in income. Change in income goes from 400 to 480. That is a 20% change in income. Plug that into the formula and we get 20. So, like I said, I don't know where 12 came from. I don't know where any of those other ones came from. If we're just looking at panel A, I don't even know why panel B is on there because it says in panel A. So it's another one that kind of lost on. Ended up getting the right answer, but I can't really explain this one. Oh well. So formulas for this one, I would know this formula. I might come back to this one. I don't know. Nadia eats chia seed pudding for breakfast. If the price of chia seeds fall, what would be the substitution effect of this price change? So chia seeds, if the price of chia seeds falls, what would be the substitution effect? Okay, so chia seeds and everything else. Price, or I guess I should just start this. Start this here. Price of chia seeds falls, so she can buy more of it now. This is 2, this is 1. All right, Nadia can buy more oatmeal and less chia seeds. Nope, she can buy the same amount of oatmeal. She can buy more chia seeds actually, because the price falls, so it's not that one. With fall in the price of chia seeds, Nadia will have more purchasing power and will buy more chia seeds. Nope, she has the same amount of purchasing power because it was only the price of one good that fell, not the price of everything or an increase in income. So that's wrong. With a fall in the price of chia seed, Nadia will have more purchasing power and will buy more of all goods. Not necessarily. She could still be like here. Like if it goes from like there, or if it goes from like there to there, then that wouldn't change the income of the goods. Yeah, so Nadia will consume less of goods whose relative price has risen and more chia seeds. So she's buying more chia seeds because the price falls, and she's buying less of those that have risen because their quantity demanded will go down. That's the only one that really makes sense. Make sure we're looking at just the substitution effect, not the total effect. So the total effect, it might bring an increase in the buying power of all the other goods, but we're just looking at substitution effect. So we're just looking at what chia seeds is going to affect. All right. Given the change in the budget constraint shown in the diagram, which of the following statements are true? So it goes back to that same thing of if y changes, then it's going to shift along y, and it's going to change along y, and it's going to shift the entire x curve. Appreciate that. Thanks. Ooh. Oh no, the meet ended. That might be why people are messaging me. Oh well. I'll go through the rest of this, and I assume I'm still recording. Yeah, I think I'm still recording. I'll go through the rest of this and post the video. So given the change in budget constraint shown in the diagram, which of these statements is true? So the price of good Y changed, so she could buy less of it, or they or whoever. So we know that Y didn't shift, that's wrong. We know that X shifted, so that's good. So yeah. All right, Aisha's angle curve for bubble tea is I equals 75C, where I is her weekly income and C is the number of bubble teas she consumes. Aisha considers bubble tea a blank. So inferior good, which means an inferior good would mean that the consumption would decrease after a certain amount of income. And that's not true because we can see that this is a linear relationship. So as long as we keep on increasing I, then consumption is always going to increase. So uh, next best option is normal good. We know that the definition of a normal good is, where is it? Consumption increases as income rises. That's perfect because we have a linear relationship between income and consumption. So that's going to keep increasing and increasing and increasing all the way to, if she has an infinite amount of money, she buys an infinite amount of, what was it, bubble tea. All right. Last one. A consumer's bundle includes good X and good Y. If good X is normal, and good X and Y are substitutes, and the price of good X rises, then the consumer will buy blank of good X and blank of good Y. So they're substitutes. So think like Coke and Dr. Pepper. If you're not picky between them, or if you want to do something, I, I don't. If you're picky about Dr. Pepper and Coke, then just pretend you aren't, just for the bit. Um, so imagine that they're the exact same thing, and the only thing that decides which one you buy is the price. That's what a substitute is. So if the price of Dr. Pepper rises, then I don't want to buy it anymore. I'm going to buy the cheaper one. I'm going to buy Coke. So price for pepper rises, then the demand for Coke is also going to rise, and the demand, oops, holy cow. The demand for pepper is going to decrease, even if the price for Coke stays the same. That doesn't look like an equal sign. There we go. All right, so if the price of good X rises, let's say this is X, and this is X, and this is Y, and this is Y. So if the price of good X rises, so the price of X rises, the consumer will buy how much of good X? It will buy, so the quantity demanded of X will be lower, and it will buy more of good Y. That makes sense? It will buy more of good Y. So less, more. All right. That's all I got. As far as formulas go, the two that I would focus on are this one. There's probably a better one that's in the textbook or was in lectures or something like that, but it's more of kind of a like a concept thing of like just know if you're looking for elasticity, then it's going to be the change in quantity over the change in income. So you might see like elasticity for like XYZ equals, percent change in Q over the percent change in Y. And that might be what your formula looks like, but this one is easier to understand for me, so that's one I'm going to have on my sheet. And then the other formula, let's see if I can find it. Oh, this one's pretty handy. The marginal utility of X over the price of X. That's kind of helpful. And then last one, this one. Marginal utility, I would do this one. Oops, this one. just so you don't get confused with the M and the M, because those are two different things. This one is marginal, and this one is one of the variables. Just like this is variable, and this is a variable, and this is a variable. All right, that's about it. I'd look over, like I said, I have these Notion notes, so you guys are welcome to kind of click through these. They should update as the semester goes on. So like I have chapter 6 notes if you want to look ahead for those. I started on chapter 7. Um, but yeah, that's about it. This video I'm going to upload to here along with a PDF of um, the exam review. I might take a picture on my note card. I don't know. Um, it's like I'm not going to have anything extra than what I said in here. So, but yeah, good luck on the test tomorrow, I guess. See you guys.